Hi, I'm Norman Wildberger, and today I'm going to show you how to solve triangles using rational trigonometry. So to start off, let's look at the simplest situation where we have a right triangle, and it has quadrants Q1, Q2, and Q3, and spreads S1 and S2. The basic facts are Pythagoras' theorem, Q1 plus Q2 equals Q3, and the definitions of the spread. S1 equals Q1 over Q3, and S2 equals Q2 over Q3. From these two, we immediately see that S1 plus S2 equals 1, and these formulas allow us to solve for all of these quantities if we know two of them, with the exception of knowing S1 and S2. So as an example, here's a little triangle that comes about from the ISO paper sizes that we use in Australia. A spread of 1/3 here. We have a right triangle. This is 8 units long, so therefore quadrants of 64. So let me briefly indicate how you might find some of these other quadrants around. This spread here plus this spread has to equal 1. That makes it equal to 2/3. If that's 2/3, then it's equal to 64 divided by this quadrant. That means that quadrant is 96. If that's 96 and that's 64, then that's 32 by Pythagoras. This h here, h divided by 64 is the spread 1/3. That means that h is 64 over 3. And similarly, p and r, just chase things around. I'll leave it to you to show that it's 128 over 3 and 32 over 3. Alright, now let's look at the general triangle. Here we are, A1, A2, A3. Quadrants is Q1, Q2, Q3, and spreads S1, S2, S3. So the typical situation is we know 3 of those, and we want to find the other 3. The simplest case is when we know all the 3 quadrants. Well, then here's one of the fundamental laws, the cross law. In this case, I've expressed it in such a way to get S1. There are actually 3 cross laws, one for each spread. Right? This one allows us to find S1 if we know the 3 quadrants. Now there's an alternate way of thinking about things in terms of the quadria, which is a restatement of this thing here. What we do is we look at the difference between 4Q2, Q3 and the left-hand side. That's called the quadria of the triangle. And let me remind you that's 16 times the square of the area. Here it is rewritten in a symmetrical form. So an alternate way of thinking about how to get the spreads from the quadrants is to first compute this quadria. Because once we know that, then this cross law tells us that the quadria divided by 4Q2, Q3 equals S1. Okay? You just get that by rearranging. Bring that over there, bring that to the other side, then divide by 4Q2, Q3. So that's how you get S1, that's how you get S2, and that's how you get S3, all from the quadria A in the numerator. Alright, now let's have a look at what happens if you know 2 quadrants and 1 spread. Let's say that the spread that we know is S1. Well, of course, it depends on which 2 quadrants we know, but the basic idea is if we know S1, we still go back to this cross law. We know S1. The rest of the equation is a quadratic equation in the 3rd unknown quadrants, whichever one it is. So it's a quadratic equation that we can solve, and we always get 2 solutions typically when we solve a quadratic equation. That means that there are always 2 possibilities. Let me illustrate that by going back up here to this diagram. If, for example, we know S1, Q2, and Q3, then this is one such possible triangle, but the other possible triangle is when this side here is oriented in this direction, still making a spread of S1 with the base. Okay? Still the same quadrants here. So that would be a new triangle which has the same spread and the same 2 quadrants. That's what this does, is it allows for those 2 possibilities. Alright, so once we've got all 3 quadrants, then we can use the spread law to find the other spreads. Because if you know all those 3 quadrants and one of the spreads, then you can quickly calculate the other 2 spreads. Okay, so the next situation is 1 quadrant and 2 spreads we know. The triple spread formula is an equation involving all 3 spreads And if we know two of the spreads, then it's a quadratic equation for the third spread. So if we know S1 and S3, for example, then there are two possibilities for S2. Again, corresponding to either this triangle or the other one where this line is over here. It would meet that one way up there somewhere. Alright, so we calculate the two solutions to this quadratic equation. And then for each of those solutions, we use the spread law to find the other quadrances. Because now we have the three spreads, and we have one of the quadrances, so we can find the other two. There's one more last situation, which is what happens if you know all the three spreads. Well, then the triangle's shape is determined, but its actual size is not pegged down. All what we can say is that the ratio, or the proportion between the three quadrances, equals the proportion between the three spreads. Alright, so that's basically it for solving triangles. Now we're in a position to do some triangle geometry. So next time we're going to look at centers of triangles and analyze centroids, orthocenters, circumcenters, and incenters. Hope you'll join me. I'm Norm Wildberger, and thank you for listening.